My Arduino speedometer project. My project objective is to find out what is the average speed of my 4-year-old's bike ride to school. To build this, I used my Arduino starter kit and the Arduino IDE coded in C++. Most of the tools I needed were already included in the Arduino Uno starter kit, so that includes the Arduino Uno Rev 3, the LCD display, and any wiring or breadboards that I needed. What I ended up buying were the Hall effect sensor for detecting a magnet. I had magnets handy as well as push buttons to include with the final product. The next step was assembling the hardware. So once I figured out how to read a circuit diagram, I connected the microcontroller to the Hall effect sensor, which output its data to the LCD display. The next step was adding an SD card reader module to write the data to a file. Adding the SD card was a bit of an afterthought, so there was a little delay while I ordered that piece and got it installed. I did run into some technical challenges related to the SD card. The first was ensuring write access, and the second was finding a working write interval. When I tested my program a few times, it seemed like it lost write access to the SD card. I plugged it into the SD card adapter and into my computer, and I had no write access. But it turns out that the problem wasn't with my program, and I hadn't corrupted my SD card. There's a lock and unlock setting on the SD card adapter, and the actual unlock setting specific to my SD card was nowhere where the guide indicated. It was actually right in the middle. So once I figured that out, I was able to redirect my focus to troubleshooting the code. But that introduced some delays because I ordered a whole new SD card, waited for it to come in, and then discovered that that wasn't the issue at all. And then I was able to redirect my focus to finding the correct write interval so that I wasn't looping through that function too frequently, and I was successfully writing to the file. In this example, you can see that I've got it writing to a file every 20 rotations of the bicycle wheel, and that seemed to work better. So the way it works is the LCD display and Arduino unit are mounted to the handlebars with a sensor fixed to the bike frame and a magnet fixed to the wheel. And every time that magnet triggers a sensor, her speed is calculated and displayed on the LCD screen. There are two display settings. One is an output of numbers, distance traveled, duration, average speed, and maximum speed. And the other is a star loop function, so that every time her speed increases, she gets an extra star. 1 star is 1 mile per hour. So when she maxes out at 5 miles per hour, she's got a full 5 stars on the display. And here you can see my crude installation of the unit. It's fixed to her handlebars with tape. A wire runs down her bicycle frame, and the sensor is fixed to the frame near the tire where that green light blinks every time the magnet passes by. So this is a function I use to write the data to my SD card. After every loop, it flushes the data to the card, and then when you push that blue button there, however misaligned it is, it closes the file. That's the pause button. It outputs a CSV file that I open in Microsoft Excel, and then I use the current time in milliseconds as a marker for distinct trips. Whenever the milliseconds value of one cell is less than the cell above it, I know that's the marker for a separate trip, and those data should be averaged separately. So this is what the collected data looks like in graph form. In blue are her average speeds, and in orange are the maximum speeds attained for each trip. You can see that her average speeds are fairly low, while her maximum speeds are much higher, which is typical of her riding style. What she usually does is have a few quick bursts of speed, but for the most part, she's cruising slowly, stopping for every beautiful leaf along the way, and I think that's reflected in the data. So my original plan for this project was to get the average speeds for different laps along the route to school. What I didn't factor into that was the learning curve for my first Arduino project, the kind of waiting with and then reckoning with the different modules, and also the whims of a 4-year-old who might not be interested in biking on the particular day when your equipment is working. So I changed my focus to just capturing her average speed for any bike ride, weekends, en route to school, or just kind of going down the street to try to wear her out before bedtime. And so I was able to capture the data that way. If I could do this project over again, knowing what I know now, I think I would use a GPS unit and a more compact microcontroller to get the project done. It'd be interesting to get the data wirelessly and just work with that technology. For this project, I wanted to use what I had handy, so it worked. But yeah, I would definitely go a different route next time. So I think the first notable success of this project is using the kit that I've had lying around for a while, and finally realizing that intention. Also, learning how to read a circuit diagram and construct something. All of my work has just been with writing code and not, working with the hardware associated with that. So I count those as successes. And on a personal note, being able to work on a project that engaged my daughter was a real treat. Usually when I tell her that I'm, working, all she sees is me staring at a computer screen. And so this was an opportunity to show her, a product that's interesting to her that was a result of mom staring at her laptop for many hours. I can't note any disappointments. I think something that I'd like to do for my next project is, now that I'm more comfortable with C++, the Arduino IDE, and libraries, I'd like to kind of build something without kind of seeking help or clues from existing projects. I've gotten over, the first Arduino project hump, and so I'd like to see how far I can go on my own. So, but other than that, there's no real disappointments. It was all a great education and learning experience.